All right, let's switch gears, and I think there are 5 problems here on computing key parameters. And the key parameters for a discrete probability distribution are the mean, and the standard deviation, and or the variance. So let's look at problem 1 here. Problem 1 says the number of suits sold per day at Suit World is shown in the probability distribution. So it's got a distribution 19, 20, 21, 22, 23, and a fairly flat probability profile, 0.2, 0.2, 0.3, 0.2, 0.1. Now these are believable, right? I don't know if the numbers are believable, but there's certainly something that a company like Suit World could just look at their records, right? They could look at the records over a period of time and see that week to week, this is the type of distribution they have. So it says go ahead and find the mean, the variance, and the standard deviation here in part A. So the mean, as we talked about before, can be hand computed by multiplying each x by its corresponding p of x and adding all of those up. So that's what this would look like. It would be 19 times 0.2 plus 20 times 0.2 times plus 21 times 0.3 plus 22 times 0.2 plus 23 times 0.1. Okay, something that you could take, standard calculator. You don't need a stats package in order to do this calculation. If you did it, you'd find the answer is 20.8. I actually kind of waited on that 20.8 because I wanted you to look up, before you calculated, look up at that distribution and see if you could have guessed that it was a number close to 21. Right? If that distribution was totally uniform, it was 0.2, 0.2, 0.2, 0.2, 0.2, then I think you would have this feeling that 21 is the average value. So it's not quite flat. It's got 0.3 on 21, 0.1 on 0.20. But can you see that with those small variations, that the answer, the average, is some number close to 21, like 20.8. So it's good to sort of develop a little feeling for things like that, so you can look at your answers and see if you're anywhere close. So you can do the same thing for the variance, because the variance, now that you've calculated the mean, is just each x value, so distance from the mean, x minus the mean, x minus mu, squared, that's the squared deviations, that quantity times p sub x. So that looks like the following. The first x, 19, minus the mean, 20.8, square that, multiply it by 0.2, which is the corresponding p sub x. If you look at the next term, then the x is 20. The distance of 20 from the mean is 20 minus 20.8. Square that, multiply it by the p sub x value for the x value 20, which is 0.2. And so on down the line, add those all up, and you see that you get the answer 1.56. Okay, easy enough, right? And 1.56 is the variance, which is the standard deviation, sigma, squared. So if we want to find sigma, let's just take the square root of 1.56 and get 1.25 is the value of sigma. Now, I'm not trying to teach you how to do these by hand. I want you to get a feeling for what these things are. You can see that the variance is all about the deviations squared. I think you can see the mean, and you can see that it's possible to sort of estimate the mean by just looking at the distribution. What I really want you to do is use your calculator, right? And if you're faced with a problem that says find the mean, variance, standard deviation of this distribution, take out the calculator, turn it on. Let's calculate the mean. We go to stat. Under stat, we go across the horizontal menu to edit. Under edit, we pick the first choice, which is edit. The first choice, edit, allows you to fill up the lists where you store your data. I would recommend you put all the x values, 19, 20, 21, 22, 23, into the L1 list. Put all the corresponding px values into L2. Go back to stat. Now go across the horizontal menu to calc. Go down to one variable stats. you're going to end up having to tell the calculator that your data is in L1, your frequencies are in L2. And then hit go, and it will calculate for you. Very top value is X bar. That is the mean. Yeah, X bar is the notation for sample data. Mu is the notation for the mean for population. The calculator's just chosen to use X bar here in this case. Now you can look down, and in this case, rather than sigma squared, you'll find sigma, and you'll see that it's 1.248, calculated for one variable stats. And then you have to pull out another hand calculator and square 1.248. When you do, you get 1.56, as we got before. All right, so I won't torture you anymore. No more hand calculations. Make sure you have a sense for how those are done, because I want you to have that. But feel free to use your calculator. Now I want to look at problem B, because problem B has got kind of another lesson in it. It says, if the manager of Suit World wants to make sure that he has enough suits for the next 5 days, how many should he buy to stock the store? So let's assume that 5 days is a week, because if you look up above in problem 1, it says the number of suits sold. Oh, sold per day. Oh, gosh. Gosh. I didn't see that myself. Okay. Let me think about this for a second. I think I want to just stop. I think I just want to stop here. All right, I'm back. Sorry, that was. I just recognized that problem 1 says the number of suits sold per day. Problem B says, tell me how many suits you need to buy for 5 days. So whatever data we calculated up in part A for 1 day, we're just going to have to multiply by 5, all right? But that's not the big part of this problem. The big part of the problem is to recognize, how are you going to answer this? How many suits should you buy so that over 5 days you have a large enough stock for your customers? And I know you're tempted to say the average, but think about what the average is. The average is such that each day, sometimes you sell more than the average, sometimes you sell less. And so if you extend that to a week, if you just used 5 times the mu we calculated above, or looks like about 104. If you used 104, well, 1 week you'd be fine. You'd sell less than 104 suits. Another week you would be able to sell more than 4. You had the 104, but you don't have more than 104. So what do you do here? The answer is that you buy more than mu. How many more? And then you can find the answer there in the empirical rule, right? Because if you look back up the distribution is mildly bell-shaped, right? It's got a peak maximum in the middle, falls off on the ends. That means it will obey fairly well the empirical rule. That means if you go 2 sigma above the mean, that number, the mean plus 2 sigma, is a number that will satisfy 95% of the weeks, if you will, or the days, right? Because 95% of the outcomes of this experiment fall between mu and plus or minus 2 sigma. So the proper answer here is, first of all, 5 times mu plus 2 sigma. The 5 being for 5 days rather than 1. The mu plus 2 sigma really is the separation between what we expect to be usual and what we expect to be unusual. It would be a 5%, perhaps a 2.5% chance if, having bought, that would turn out to be 116 suits, as you can see right here with this calculation. That would be very unusual for you to have a week in which you sold more than 160. Now, if you wanted to absolutely cover your bases, buy mu plus 3 sigma or 4 sigma. However, now if we were in an economics class, you'd learn that inventory costs money. You want to minimize your inventory. You don't want to carry a ton of inventory. Your inventory comes at the expense of your cash. And so mu plus 2 sigma is probably the best choice. So there it is. 5 times mu plus 2 sigma comes out to 116. Okay, let's pause here and go to problem 2. All right, problem 2 in computing key parameters of discrete probability distributions is a lot like problem 1. There's the distribution, x values from 6 to 10, 6, 7, 8, 9, 10. Probabilities, actually the probability distribution, that explains it. The probability distribution is actually identical to that of problem 1. So find the mean, the variance, and the standard deviation. Let's do what the cool kids do, and let's turn on the calculator. Let's go to mem. Let's go to 4 on mem, which is clear all lists. Let's enter that. It says I'm done. Go ahead. Fill up the lists. I've just gone to stat and to edit. I am going to go over to list 1. I'm going to enter 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. Check that I did that correctly. I did. I'm going to go to list 2 now and enter the probabilities 0.2, 0.2, 0.3, 0.2, 0.1. I'm going to check that out. 2, 2, 3, 2, 1. I'm going to go back to stat, over to calc, down to one variable stats. It wants to know where's my list. It's in L1. Where's my frequency list? It's in L2. And it says go ahead and calculate. And I get x bar, or mu, 7.8. I get sigma, 1.24899996. And so sigma squared is 1.56, I believe. 559 or 1.56, yeah. So just that quick, real time, I just did that problem. So part B asks approximately how many arrangements should Rish expect to deliver in a week? I got to go back to the top so I don't make that same mistake. And I did make that same mistake. Rish Florist determines the probabilities of the number of flower arrangements that they deliver each day. Yeah. Approximately how many arrangements should Rish expect to deliver each week? So I don't know if a week is 5 days or 7 days. Let's say it's 5. Rish takes the weekend off. And the question is different. The question before on problem 1 had to do with usual versus unusual. That's sort of what this is, but there's a key word as far as I'm concerned here. It's expect. How many arrangements should they expect to deliver each week? And the thing about these key parameters is the expectation value, sometimes called the expected value, is the mean. It is the value that if you exercise this experiment is, whatever this experiment is summarized by this discrete distribution. And if you run this experiment over and over again, keep records at Rish Florist day after day after day after day, then you'll find that on average the value that you see is equal to the mean. So I think the right answer here is if a week is 5 days, it's 5 times mu. All right, and there you have it. Okay, we'll go away and come back and take on problem 3.